Hello everyone, myself Sravanthi, working as an assistant professor in MLR Institute of Technology in the Department of Data Science and Cybersecurity. Today our topic is LALR of 1 parser. So here we are going to cover what is LALR of 1 parser and what are the steps that we need to follow to construct a parsing table, LALR of 1 parsing table with an example. LALR parser is a look-ahead LR parser. It is nothing but it's a look-ahead parser. It is the most powerful parser which can handle large classes of grammar. Here, by using this LALR of 1 parser, we can handle the large classes of grammar. The size of CLR parsing table is quite large as compared to other parsing tables. See, here we have already constructed, we have already done with CLR of 1 parsing table. So, when compared to LALR of 1 parser, the CLR of 1 parsing table is quite large. It's quite large when compared to LALR of 1 parser. LALR of 1 parser reduces the size of the table. It reduces the size of the table. Same what we have done in the CLR of 1 parser, the same thing is applied over here, but we are going to reduce the size of the table. By applying some rules, we are going to reduce the size of the table. So that is the main difference for CLR of 1 parser and LALR of 1 parser. LALR reduces the size of this table. We are going to reduce the size of the table when compared to CLR of 1 parser. LALR works similar to CLR. The only difference is it combines the similar states of CLR parsing table into one single state. See, till we have discussed CLR of 1 parser, the difference here is similar states are combined. Here, what we have done in the CLR of 1 parser is we are going to calculate LR of 0 items plus look ahead symbol plus look ahead. So, the difference is here only in the CLR of 1 parsing table, based on the look ahead symbols, we are going to get that many number of states. Even the productions are same, the look aheads are different. So, we have gone for the new states. Coming to here in LALR of 1 parsing table, what we are going to do is, when we are going to construct the parsing table, the productions which are same, only the look aheads are different. Still, we are going to combine those two states as the productions are same, but the only differ in the look ahead symbols. So, in that case, we are going to combining and we are going to reduce the size of the table. So, that is the difference for the CLR of 1 parser and LALR of 1 parser. The general syntax becomes A tends to alpha dot B comma A, where A tends to is a production and A is a terminal or right hand marker. So, nothing but the general syntax will be like this. A tends to alpha dot B comma A. Here it is nothing but this is the production and it is nothing but the terminal. It is nothing but we can also tell it as a terminal or we can also call it as right hand marker, that is $. So, LR of 1 items is equal to LR of 0 items plus look ahead. LR of 0 items plus look ahead. So, here what we have discussed here, there are 4 types of parsers we have in the bottom up parser: LR of 0, LR of 0, SLR of 1, CLR of 1, LALR of 1, LALR of 1. So, these two follow LR of 0 parser. These two are LR of 0 and SLR of 1 are constructed based on LR of 0 parser. And coming to CLR of 1 and LALR of 1 are constructed based on LR of 1 items. LR of 1 is nothing but LR of 0 plus look ahead symbols. LR of 0 plus look ahead symbols. This is the only difference for these parsers. So, what are the steps that are required to construct LALR of 1 parsing table? First, convert the given grammar into augmented grammar. Then insert dots at the beginning of RHS of all the productions and find LR of 1 collection of items. To calculate LR of 1 collection of items, we need to follow LR of 0 plus look ahead symbols are going to be there. Then afterwards construct LALR of 1 parsing table. So the first is we are going to find the augmented grammar. For the original grammar, we are going to add for new grammar, new starting symbol. So that is nothing but, for example, in the original grammar, there is S in the original grammar. Then coming to the augmented grammar, there will be a new symbol, that is S dash tends to S. S dash tends to S. Here, why we are going to add these new production is, it indicates that to parser when it should stop parsing. It indicates the parser when to stop parsing. So the dot before S indicates that it is already read by a compiler. After S, dot is there, is nothing but it is yet to be read by a compiler. So this is the difference for the original grammar and the augmented grammar. Augmented grammar is represented with S dash. It shows the difference for the new grammar and the original grammar and the new grammar. So let us take one example and construct the LALR of one parsing table. It is same like the previous one. The only difference is in the construction of a LALR of one parsing table. So this is nothing but the augmented grammar which we have constructed. S dash tends to dot S. For these, this is our original grammar. For these original grammar, we are going to add the augmented grammar. So S dash tends to dot S. So let me write the augmented grammar for this. S dash tends to dot S. After dot there is a production, that is after dot there is a non-terminal. So let us write the non-terminal productions. S tends to dot A. After dot there is a non-terminal, that is A. So let me write the non-terminal productions. A tends to dot B. So these are the four productions. It is nothing but in I0 state. This is in I0 state. This way we have constructed for SLR of 1 and LR of 0. But coming to here, the difference is we are going to have the look ahead symbols. As this is our start symbol, we are going to have dollar. As it is our start symbol, we are going to have dollar. Coming to here, after dot only one production, one symbol is there. So directly we have written. There is no more terminals, non-terminals are there. So that is the reason we are going to copy these dollar here. These two productions are written just because of this production. After dot, there is one non-terminal and there is one more non-terminal, that is capital A. So what we are going to do? First of A. What is first of A? First of A is A comma B. Nothing but A by B comma A by B. A by B comma A by B. So this is our I0 state. Now we need to calculate the we need to apply goto function on this state. We need to apply goto function on this state. So what we are going to have here? Goto let me construct here. It will be easy. Go to I0. Let me write here. I0 state. S dash tends to dot S comma dollar. S tends to dot A comma dollar. A tends to A comma A by B. A tends to dot B. A by B. A by B. So this is our original grammar. I0 state. It is in I0 state. Now we are going to apply goto function on this I0 state. Go to I0 comma capital S. Now what it happens when I apply goto function on any state, on any terminal, is nothing but the dot is moving to the next position. So S dash tends to S dot comma dollar. So this is my I1 state. This is my I1 state. Now go to I0 comma capital A. I0 comma capital A. S tends to A dot A comma dollar. As after dot there is a non-terminal. So we need to write the non-terminal productions. We need to write the original non-terminal productions. We are not going to apply goto function on the productions which we are going to write just because of the previous production. A tends to A comma dollar. A tends to dot B. A tends to dot B comma dollar. Even though when we are copying the productions just because of the previous production, the look ahead symbols are not copied. The look ahead symbols are written just because of the previous production we are writing these grammars. So we need to apply the look aheads based on that production. See, after dot there is no non-terminal is existing. So directly we are going to write the look ahead symbols of that production to the previous productions. So this is I2 state. I2 state. Go to I naught comma small a. I naught comma small a. A tends to A dot A by B. A is a non-terminal. So we are going to write the dot A tends to dot B. So after this there is no non-terminals existing. So we are going to copy same look ahead symbols I2. So this is I3. Now go to I naught comma small b. I naught comma small b. A tends to B dot. It is I4. A tends to B dot. It is I4. Now apply. Go to function on I2 state. Go to I4. I naught state is completed. Now reading all the predictions. Now go for I1 state. I1 it is already completed. Then move to the I2 state. I2 comma capital A. S tends to A dot comma dollar. S tends to A dot comma dollar. It is also completed. I5 state. I5 state. Go to I2 comma small a. Go to I2 comma small a. A tends to A dot A comma dollar. So dot is dot, after dot there is a non-terminal. A tends to dot A tends to dot B. So what are these productions? These are of non-terminal. There is no non-terminals existing after the dot. Only one non-terminal. According to case 2 we have written. So this is which state? I6 state. See, the productions are same, but what it is, the look aheads are different. So we are going to write here new state I6. Now go to I2 comma small b. So what we are going to have? A tends to B dot comma dollar. So what type of state? B dot. B dot is there. Here we didn't write here. B dot comma A by B. B dot is there, but the look aheads are differ. Here A by B and here it is dollar. So it is I7. It is I7. Now I2 is completed. Then move to the I3. Go to I3 comma capital A. A tends to A dot A by B. It is completed. It is I8. I8. Now go to I3 comma small a. A tends to A by B. After dot there is a production, non-terminal is there. So we need to write these non-terminal productions. Dot A tends to dot B. So after these non-terminal, there are no more non-terminals are existing. So just copy the look ahead symbols of that production. So check whether the same production is existing. Yes, the same production is existing, but the look aheads are also same. So write the same state I3. Same state, that is I3. Now go to I3 comma B. I3 comma B. So I3 comma B is nothing but A tends to B dot comma A by B. These and these are matching. So I4. I4. Now next go to I3 is completed. I4 is done. I5 is completed. Then we have I6. Go to I6 comma capital A. I6 comma capital A. A tends to A dot comma dollar. A tends to dot comma dollar. it is completed. After dot, there is no terminal or non-terminal. So it is completed. We have done I7, I8 and we are having I9. I9. Now apply go to function on this. Go to I6 comma small a. I6 comma small a. Let me write here. Go to I6 comma small a. I6 comma small a. So what we are going to have I6 comma small a tends to a dot a comma dollar. After dot there is a non-terminal, so write a tends to dot a tends to dot b. So after dot only one non-terminal is existing, so you just copy the same look ahead symbols. Check the same production is existing. Yes, it is existing. So directly write I6 state. The productions are same and the look aheads are also same. Next, go to I6 comma small b. A tends to b dot comma dollar. B dot comma dollar. It is existing already. It is I7. I7. I6 is completed. I7 b dot it is ended. I8 it is completed. I3 already it is existing. We have applied go to function on I3. So it is also done. I6 completed, I7. No new states are there. So these go to functions application will be done. Nothing but LR of one collection of items is done until we get a new state. If we won't get a new state, then we stop applying the go to function on that particular states. So we have done reading all the states. Nothing but we have done applying the go to function on all the states. So this is of the LR of one collection of items. After completing this, we are going to calculate the data flow diagram. So directly we can do this data flow diagram instead of calculating like this. Directly we can apply over here, or else we can do like this. So same thing, I0 state, same productions are there, I0. Next, I0 on capital S, I0 on capital S, what I have? It is moving to I1. I1 nothing but S dash tends to dot S comma dollar. Now I0 on capital A. I0 on capital A. It is moving to which state? I2 state. So we are going to write these productions here in these. I2 on I0 on small a. It is moving to which state? I3 state. I3 state. Next, I0 on small b. It is moving to I4 state. I0 on small b. It is moving to I4 state. Next, I1 is completed. There are no new states. Then afterwards we have applied go to function on I2 state. I2 on capital A. It is moving to I5 state. I2 on capital A. It is moving to I5 state. I2 small a. It is moving to I6 state. I2 small b. It is moving to I7 state. I2 is completed. Then go for I3. I3 on capital A. It is moving to I8. I8. I3 on small a. It is moving to I3. So nothing but self loop A. I3 small b. It is moving to I4. It is moving to I4 state. I3 is completed. Next, I4 it is only one state, that is final. I5 it is final. I6 go to I6 comma capital A. It is moving to new state, that is I9. I6 comma small a. It is moving to I6 state. Nothing but self loop we are going to get. And I6 small b. It is moving to I7 state. Small b. It is moving to I7 state. It's like a DFA diagram. When we are applying one input, it is moving to either to the new state or standing in the same state. So this is nothing but data flow diagram. Now for this we are going to construct a LALR of one parsing table. LALR of one parsing table. So here to calculate the LALR of one parsing table, what we have done for the CLR of one parsing table is the number of states, how many number of states are there, that many number of states we have drawn a rows, that many number of columns we have taken. So how many number of states we have? 9 states are there. So nothing but I0 to I9 are the number of states, nothing but number of columns we have done. I0 to I9. So then after what we are going to do is here, we are going to the only difference for CLR of one parsing table and LALR of one parsing table is if we find the productions are same, if the look aheads are differ, still we are going to merge those two states. We are going to merge the two states in LALR of one parsing table. But coming to CLR of one parsing table, even the states, the look aheads are different. We have plotted that many columns are going to be there. So that is the only difference for the CLR of one parsing table and LALR of one parsing table. So let me check here. What are the states which are having same productions? See here. Let me check. I1 same state productions are there? No. I2, A dot A. It is not there. I3, check I3, A dot A, A dot A. See here, I3 and I6. I3 and I6. In I3, we have same productions in I6 also. But here the look aheads are A or B and the look aheads are here dollar. Still the look aheads are differ. We are going to merge those two states. I3, I6. Same way you check for the remaining I4 and I7. I4, I7. I4, A tends to B dot, A by B. A tends to B dot, dollar. Here it is dollar and here the look aheads are A by B. So this is one more state. Next, check for this another I8. Any same thing is there? Yes, I8 also. AA dot A by B, AA dot dollar. I8 and I9. I8 and I9. I8 and I9. So let me write here I3, I6 are same. I4, I7 are same. I8, I9 are same. I3, I6, I4, I7, I8, I9. So these are having same productions but look aheads are different. So coming to the here in LALR of Parser, we are going to merge those states even the look aheads are different. We are going to merge those states. So how we are going to merge? I3, 6. So I can write I suffix 3, 6. I4, 7. I8, 9. A8, 9. Coming to the CLR of one parsing table, we have plotted in the parsing table I0 to I9 number of columns we have done. Number of rows we have constructed in CLR of one parsing table. But here we are going to reduce the size of the parsing table. So that is the differ for the CLR of 1 and LALR of 1. Here how we are going to merge those is when both in the given states, if the productions are same and the look aheads are differ, still that is the case, we are going to merge those states. We need to identify what are the productions same here in each state. That productions, check the look ahead symbols. If the look aheads are differ, still we are going to merge those states. If we are going to do like this, the number of the table size is going to reduce. Now how we are going to plot this? Let me show here. See here, in a we merge the similar step. I3, I6 are similar except their look aheads. I4, I7 are similar except their look aheads. I8, I9 are same except their look aheads. So whenever there is 6 or 3, we make it as 3, 6. Wherever there is 4 or 7, we are going to combine it as 4, 7. 8, 9, we are going to combine. Either if we find 8 or 9, we are going to merge those two states. I8, 9, I3, 6, I4, 7. See, this is the diagram we are going to get here. So, I0 on A. I0 on small a. What I have I0 on small a, it is moving to I3. So what we are going to do, as I3 and I6 are pointed to same, so wherever you find I3 or I6, we are going to write like I36. Nothing but as it is in action part, we are going to write it as S36. S36. I0 on B, we are going to have S47. Same. So this way we are going to plot this one based on that diagram. As we can see that 36 row has same data twice. So see here we got duplicate data. So the duplicate data is nothing but the 36 is repeated, 47 is repeated, and 89 is also repeated. So these duplicate data are going to be removed. If we remove this, the size of it will be reduced. And we are going to find the final LALR of table is this one. We are going to find the table like this. Once again, we will see here what will be the diagram for that. So let me erase. By using this data flow diagram, we will be plotting how we are going to find the look ahead symbols. Here what we are going to do is, we are going to have a table. LALR of one table. Here action, and this is go to. In this go to and action, we are going to have the terminals and non-terminals. So first we need to identify what are the terminals and what are the non-terminals. Here in action we are going to write the terminals. So what are the terminals according to these diagram are A, B and $. And what are the terminals, non-terminals in the go to function? A and capital S. These are the non-terminals in go to function. Coming to the action, we have three things: terminals A, B and $. So what are the states we have? I0 state, I1, I2, I3, I4, I5, I6. In this way we have written. So here what we are going to do is, we are going to merge I3 and I6. So nothing but directly I am writing I36. I4, I can write it as 47. I47. Next, I5. There is no merging of I5. I6 is already merged, completed. I7, it is already completed. The next I have is I89. I89. So these are the states. So we need to write these one in a order. I0, I1, I2, I3, I4, I5, 6, 7, 8, 9. So in this way, in order we have written. Now, I0 on small a, where it is going? I0 on small a. Check it from this diagram. I0 on small a, it is moving to I3. I3 is nothing but what it is? S36. Shift 36. I0 on capital S, where it is going? I1. I0 on capital S, it is moving to 1. I0 on capital A, it is moving to 2. I0 on capital A, it is moving to I2. I0 on small b, it is moving to 4. Nothing but S47. S47. As 4 and 7 are having same production but different look ahead symbols. I0 is completed. The next, I1. Let me go for I2. I2 on capital A. I2 on capital A. It is moving to 5. I0 on small, I2 on small a, it is moving to I6. I2 small a, it is moving to 6. Is nothing but S36. Nothing but shift 36. I2 small b, it is moving to 47. S47. S47. Next, I2 is completed. Next, go for the I3. I3 on capital A. I3 is nothing but I36. On capital A, it is moving to 8, 9. Moving to 8 is nothing but 8, 9. I3 on small b. I36 on small b. Where it is moving? Small b, it is moving to S47. S47. I3 on small a, it is moving to self loop. I3 self. So we are going to write it as 3. 3 is nothing but 3, 6. 4 is nothing but 4, 7. 6 is nothing but 3, 6. 8 is nothing but 8, 9. I3 is completed. The next we have I4. It is done. I5. It is done. Next I6. I6 on capital A. I6 nothing but I3 6 on capital A. It is moving to I8 9. I3 6 on small b. It is moving to 4 7. Capital A. It is nothing but moving to 3 6. Self loop. It is completed. Now find out I5. I5 is also completed. Now find out what are the final state here. What are the final states here? So find out what are the final states here. I1. I1 is our final state. I1 is our final state because dot is finding. Next, I2 there is no final state. I2 there is no final state. I4 7 is final state. A tends to B dot. Final state it is there. Next, check I8 9. Next, I5. Check 3. A tends to A, it is not there. I1, I4 7, I8 9 and I5 are the final states we got. Now I1, check for the I1. What is the I1 final state? S dot. As it is our start symbol, we need to place in the place of dollar accept. In the place of dollar accept. So now next I4 7. I4 7 is our final. You check for the I4. A tends to B dot. Coming to the 7 production is also having A tends to B dot. But here the lookaheids are A by B and the lookahead are here is dollar. So first one we need to write, we need to find out the reduce function. Nothing but for the final states one we are going to write. We need to give the reduction numbers. So let me write the original grammar here. S tends to A tends to A tends to B. This is R1, this is R2, this is R3. So what is the production I4? A tends to B. So in the place of I4 7, the production number is, reduction number is R3. And what are the lookahead symbols of I4? A comma B, A comma B. And in the 7 what I have? Dollar. So nothing but when I merge these two states, the lookahead symbols are in the place of all the lookahead symbols, we are going to write the reduction numbers. R3, R3, R3. These two are from I4 and this is from I7. Even the productions are merged, the lookahead symbols, we are going to plot the reduction states based on that. Now I4 is completed, I1 is completed. So the next we have is I5. Check I5. S tends to AA dot. S tends to AA dot. The reduction number is R1. What is the lookahead symbol? Dollar. So we are going to write here R1. We are going to write here R1. Next, I5 is also completed. Next, I8 9. I8 9. You check the I8 9 production. So AA dot. This is our production. R2. I8 9. The reduction number is R2. What are the lookaheads I have here? A by B and here I have dollar. So nothing but here we are going to write it as R2, R2, R2. R2, R2, R2. So this is nothing but LALR of one parsing table. The difference for CLR of one parsing table and LALR of one parsing table is the number of rows, the number of columns are reduced. Here the size of the table is reduced. We are going to reduce the size of the table. Here in CLR of one table, we have plotted I0 to I9. I0 to I9 rows we have constructed. But coming to here in LALR of one table, we have reduced these number of rows. We have reduced the size of the table by taking the same production numbers, same states which are having the same productions but different lookahead symbols. Those states are merged and by using that the LALR of one table size is reduced. So that is why when compared to the CLR of one parsing table, LALR of one parsing table is bit easy or it takes less time when compared to CLR of one parsing table. CLR of one parsing table is very large size. It takes large amount of time and the size of it is very large. So coming to the overview of this one is, first we need to find out the augmented grammar for the given example. Then we are going to have the look ahead symbols including the LR of 0 items. For the augmented grammar, we are going to find the LR of 0 collection of items plus look ahead symbols. Nothing but we are going to calculate LR of 1 items. After calculating the LR of 1 items, we are going to check what are the states having the same productions. The states which are having the same productions are merged together and we are finding the what are the final states here. Then afterwards, we are going to calculate the LALR of one parsing table. In the table, we are going to have two things, that is the action part and the go-to part. So in the action part, we are going to place the terminals and in the go-to function, we are going to have the non-terminals. Coming to the go-to function, we are just going to ignore the states. We are just writing the numbers. Coming to the action part, there are 4 types of actions we have, but here we are going to use 3 parts: shift, reduce and accept. Once the given grammar is accepted, we are going to write it as accept. The states which are reduced and reaching the final state, nothing but we are going to use reduce number. So how we are going to write these reduced numbers are, first go to the original grammar and give the reduction numbers. By using that reduction numbers, we are going to plot in this LALR of one parsing table. So this is about LALR of one parsing table. Thank you.